All right, so now that we've gotten an in-depth understanding of Swift protocols and delegates, it's time to work on the heart of the problem of this Klima app, which is to work with APIs so that we can fetch live weather data from across the internet. Firstly, what is an API? Well, it stands for Application Programming Interface. And the official definition is that you can consider it as a set of commands, functions, protocols, and objects. And APIs can be used to create software or to interact with an external system. And the beauty of an API is that it provides developers with standard commands for performing common operations, so they don't have to write the code from scratch. Now, we've already been using APIs. When we've been creating our iOS apps, we've been using the APIs that Apple has created. And these are types of APIs that you would use to create software, right? So whenever we went to the docs, we've been getting hold of the API reference. And when we're working with these classes that Apple has created, for example, the AV audio player, then these are the standard commands for performing common operations, such as playing a sound. Now, in addition to the APIs that are used to create software, there are also APIs which are used to interact with an external system. So, for example, if you've ever seen in the Tinder app where they have this section called shared friends or shared interests, where do they get this data from? Well, when you log into Tinder using your Facebook account, Tinder actually asks Facebook for this data so that they can populate it into their app. So effectively, you can consider an API as simply just a contract. It's the contract between the developer and the API provider. So for example, when we're building our weather app, because we need to populate our app with live weather data for all locations across the world, we're going to be using OpenWeather Maps API that they provide. And in this case, by using the API, we're effectively entering in a contract where we say that we'll use the methods that you provide and we'll abide by the rules that you set out in your API docs. And in return, you'll promise to keep all of your requirements the same so that our app doesn't crash because you've changed something. So in this case, we have our app and we have the API provider. And what our app is going to do is it's going to use the API. And when the user types in a city name in our app, we're going to pass that city name to OpenWeather using the API that they have set out for formatting this request. And then OpenWeather in response is going to send us the live weather data so that we can use it in our app. So if you head over to openweathermap.org/API, you can take a look at the documentation for the API that they provide. So you can get things such as the current weather data, the hourly forecast, the 16-day daily forecast, and a whole bunch of other things as well. Now, because they are responsible for hosting the data, keeping it updated, they have to make sure that people don't abuse this service. So very often, these open APIs will ask you to sign up for an API key. And that key is going to uniquely identify you as a developer. So the first thing that we need to do to work with the API is if it requires an API key, such as OpenWeatherMap, then we have to sign up. And it's completely free and they don't need any credit card details. They just want you to create a new account there. Once you've signed up, then you should be able to see a page that looks like this. And you should head over to this section called API keys. And here you should be able to see your custom API key that will allow you to use this API service. Go ahead and copy your API key and keep it somewhere safe. And now we're going to see how we can use this API service. So the data that I want is the current weather data. So I'm going to go ahead and click here to take a look at the documentation. You can see that you can get the current weather data for a location by the city name, by the city ID, by geographic coordinates with latitude and longitude, by zip code, and a whole bunch of other things that you can read about. Now, in our case, we want to get the weather for a particular city name. So if we go ahead and take a look at their example API calls, you can see that the city name comes after this parameter called Q, and then you also have to supply what's called an app ID, and this is your API key that we got just now. So let's try and structure this API call using our own API key. So first things first, let's go ahead and copy this API call. So it's api.openweathermap.org/data/2.5/weather. And then we have a question mark. And the question mark denotes the beginning of the queries. So these are the queries that you're sending to OpenWeatherMap. And it's a bit like the inputs to our Swift functions. We have to have a name or a parameter name. So in this case, Q denotes the city name. And then we have an equal sign, and then we pass in the name of the city that we want to check the weather for. So let's go ahead and copy this. And we're going to paste it into our browser. And I'm going to delete the part where it says city name in brackets, because I'm actually going to put the actual name of the city that I'm interested in. So London. Now that I've got my query as London, if I go ahead and hit enter, you'll see I get an error. And it says invalid API key. Please see this address for more information. So once we take a look at this address, you'll see that the problem is because I haven't added in my API key. So I've registered it, I've copied it, but I now have to put it into my query. As you can see in the sample query, there is a parameter name called app ID, and after the equal sign, you have to put in your app ID that you got by registering with OpenWeatherMap. Let's head over to our URL and let's start off our list of parameters or inputs with the question mark. And then let's add the name of the parameter, which is app ID, all in lowercase, and then an equal sign. And then we're going to paste in the app ID that we got from OpenWeatherMap under the API keys section. And then after that, we're going to tag on another parameter or another input. So we're going to use the ampersand to signify that we're done with this app ID parameter input. And we're now going to add the Q parameter, which is going to denote the city name. And after the equal sign, I'm going to put in the name of the city that I'm interested in, which is London. And now if I hit enter, you'll see that I'm getting live data as of this moment right now. What is the weather in London? So cloudy as usual. Now, if you're not getting this data back, it might be because your app ID or your API key hasn't yet been activated. It usually takes them a couple of hours to do this, so it might be worth coming back and trying it the next day. But for me, it often takes about 5 to 10 minutes before they actually activate my key. So it might be worth getting a cup of tea and coming back to try it again later. Now, the second thing you might be wondering is when you're seeing this data come back, you probably won't be seeing it in this pretty sort of tree structure. Instead, you'd probably be looking at the data that's coming back that looks like this. Now, in order to get it turned into a tree structure, which is much easier for us to be able to see and understand as humans, then I recommend getting this free Chrome extension called JSON Viewer Awesome. And once you install it and activate it, then it will automatically detect when you're getting JSON formatted data, and it will format it correctly for you. So now that we've seen that we can structure our API call by adding our different parameters after the URL, separated by ampersands and with the sort of key value kind of format, where we have the name of the parameter, an equal sign, and the value that we're sending over to the API provider. So as a challenge, I want you to take a look at the API docs for getting the current weather data, because you might notice that in the data that we're getting back, the temperature for London is 293. So don't worry, I'm not actually burning right now. This is not the temperature in Celsius or Fahrenheit. It's actually in kelvins, which is the scientific unit of measure for temperature. In order to convert it into a number that we actually can understand, OpenWeather Map provides a parameter called units, and you can set it to be imperial or metric. So go ahead and update your URL, your API call, so that you have the temperature getting back in either metric, Celsius, or imperial, which is Fahrenheit, depending on whichever one you find easier to understand. All right, so all we have to do to tag on another parameter is to add another ampersand. And in this case, the name of the parameter is units. And remember that when you're adding these parameter names, because this is effectively our contract, the API that we're using to get data from OpenWeather Map, you have to make sure that you're spelling it exactly the way that is prescribed by them. Otherwise, they won't know what you're talking about. So the units in my case is going to be equal to metric. I can't understand Fahrenheit, but now once I put that in, I can see that in London, it's about 19.97 degrees, and that feels just about right. At the moment, we're making this request through our browser. How can we do the same thing, but from our app? Well, let's get back to our project, and in the model folder, I'm going to create a new file, which I'm going to call the Weather Manager. So it's going to be a new Swift file, and I'm going to name the file Weather Manager. And inside this brand new file, we're going to create a struct, which is called Weather Manager. And one of the first properties we're going to create in our Weather Manager is going to be the weather URL. And in my case, I'm simply going to copy exactly what I have in my browser at the moment, and I'm going to paste it in here as a string. Now, the part of this URL that is going to change is going to be this London input, because I'm going to use different cities depending on whatever the user typed in. So notice how you can actually arrange each of these parameters in the URL in any order you like. You can have units equals metric, then Q equals London, that works, or you can even have the app ID right at the end, like so, and it would work. It doesn't actually care about the order. It looks for the keys and gets the values. So in our case, I'm actually going to get rid of this and Q equals London, because I'm going to add that programmatically a little bit later on using what the user typed into the UI text field. So I can create a method in my Weather Manager called fetch weather, and this takes an input, which is going to be the city name, and that's of course going to be a string data type. And then inside this method, I'm going to create the URL string, and it's going to be a combination of the base string, which is the weather URL that we've got up here. And then at the very end, I'm going to tag on another ampersand, the Q, which is the parameter name, the equal sign, and then in the string interpolation, I'm going to insert the city name. So now I should be able to go into my weather view controller and create a new weather manager and set it equal to a new weather manager struct and initialize it with a set of parentheses. And when my text field did end editing, and before I reset the text field's text, I'm going to use the text in the text field. So I'm going to write let city equal search text field dot text. And because this property is an optional, and I want to actually pass over to my weather manager a definite string instead of an optional string, I'm going to use an iflet to optionally unwrap my search text field.text property. So now my city property is a proper string, and I can use it when I call weather manager dot fetch weather, and the city name is this city that the user has entered. So now, if you want to assure yourself that everything's working, you can actually create a print statement that prints out the URL string, and when you run the app and you type in a city name and hit either the search button or the go button, you should see the final URL that's been formatted together. So you see this entire weather URL up to here metric, and then we tag on the and q equals Paris. And just as a safety check, we can copy this and paste it into our browser and check to make sure that it actually works. Now all that's left to do is to go across the internet from our app and fetch the actual data back. And that is something called networking, which is what we're going to talk about in the next lesson. So I'll see you there.